Okay, so in front of us we have an RTX 2080. This is the EVGA XC Ultra, I think, or maybe XC Gaming. But anyways, this card was sent to me by a customer who asked that I repair for them. If you're looking to get your graphics card repaired by me or somebody like myself, I have a Discord server with a repair request section and the contact details of a few qualified professionals living in Germany, US, and UK, and also Indonesia. But anyways, since this, unlike my regular videos, we're not going to start with a resistance and voltage check, and that's because this is a half-working card. So let's go ahead and boot into Windows and see exactly what's wrong with the card. Okay, so as you can see, the card's running. I should note that if you're wondering why the fan is spinning at max speed, that's because the cooler itself is damaged. I'll have to get to this later, but otherwise the max fan spin is not related to the card's failure. So I should note that the problem with this card, as you'll undoubtedly notice soon, is that it intermittently crashes. As in, sometimes you can use it for hours and then it'll crash, and sometimes you can only use it for a few minutes. And then after it crashes, if you try to restart the computer, the card is no longer detected. So this is actually very hard to capture on camera. So what I'm going to do is I'm going to leave my camera recording, and hopefully after enough time you'll be able to see this, so that we can then move on with the actual diagnosis itself. So the way we can tell that the computer has crashed is actually by looking at the caps lock button. Now I should note that the reason why this is relevant is because on a responsive computer, this light is supposed to change, either here or at the actual top right of the keyboard. Okay, so just to be clear, what I mean is that the caps lock LED switches from an off to on state or an on to off state if Windows itself is working as normal, or if you're in the BIOS or in some other, responsive operating system. What you'll see later on is that after the RTX 2080 crashes the system, when we go to press the caps lock key, the LED doesn't switch, which is how we know that yes, Windows has actually stalled, and by extension, it's the graphics card's fault. Okay, so it's actually crashed. It's from looks of it, it's been dead for a while now. But anyways, if we go over to the keyboard, remember that before that we had a caps lock light and that it was actually responsive. Okay, if we click the caps lock light, no response. But we can see that the I'm not sure how obvious it is, the num lock light is on, and again, no response. And so we can tell that the actual computer itself has stalled, and in fact, let's try resetting the computer. Let's try turning it off and on to see if it can actually be detected this time. Okay, so the computer's off, and power supply on, turning the computer on. Not detected. You heard those beeps. That means not detected. Okay. So we have our fault again. Our intermittent fault is back, which means actually there's one more thing I want to show, but I need to get the card functioning again in order for this to be obvious. Okay, so in order to demonstrate the final thing that's wrong with the RTX 2080, it's actually best if I show you what's supposed to happen on a working card. So this is a Strix 1080 Ti. This was the Strix 1080 Ti that I fixed a couple weeks ago in my Strix 1080 Ti video. But anyways, now notice that when I press the reset button, okay, pay attention to the screen. When I press the reset button, the screen clears, and it clears almost instantly. Watch. There we go. As soon as I press the reset button, the screen blanks, which is how it's supposed to be. Let me show you what happens when I do this on the RTX 2080. Watch what happens when I press the reset button now. Okay, reset is pressed, but the screen still has an image. But in a moment when the computer posts, there we go. The moment it posts, the screen clears, and then the BIOS splash screen loads. This is not what's supposed to happen. What's supposed to happen is that when I press this reset button, the screen is supposed to go blank. But in this card's case, due to the fact that it's faulty, it doesn't go blank. Instead, it takes a few seconds. So anyways, let's take the card apart and discuss exactly what's gone wrong, as this is actually our biggest hint. Okay, so as you saw, when we press the reset button, the card does not clear its image from the monitor, and so we know that our problem is reset related. So on this particular card, the reset pin, this would be pin A11 on the PCIe pinout, connects to a logical AND gate over here. So that's of course our first suspicion. So let's turn on the card and see if we can spot anything that looks off. So we're going to start by measuring the output of the logical AND gates. So as you can see, we have 1.8 volts. Okay, so the way it works is that this logical AND gate, it takes 1.8 volts for VCC, it seemingly takes 1.8 volts for the second inputs, and then finally it takes 3.4 volts from the PEX reset pin at the first input on the bottom left here. But as you will notice, when we turn on the card and we measure this input, we will get about, we're not going to get 3.4 volts. Instead, we get 55 millivolts, which is not high enough. Yet, despite the fact that we're missing one input, we still have a 1.8 volts output. Okay, so I just want to make it clear that the way these logical AND gates work is that they have 2 inputs and VCC, and they need both inputs and VCC present in order to output something, yet this one still outputs something despite missing its first input. Which means that we have a dead logical AND gate. The reason why we don't have that PEX reset pin is actually due to the fact that we have corrosion on the back of the board. I'm not sure how obvious it is on camera, but if you look, anyways, like I mentioned, if you look over here, you might be able to see some green marking on the PCB. This is because the actual trace itself has been severed, and that green is actually just corrosion from the copper. Okay, so before we get to the actual repair itself, there's 2 more things I want to show. So the first is that sometimes when we turn on the card, the logical AND gate output is 0 volts as it's supposed to be. If we look at the logical AND gate output, when we turn on the card, we have 0 volts. And finally, sometimes when we turn on the card and the output is 1.8 volts, when you press the reset button, this 1.8 volts is not cleared to ground. Instead, it stays at 1.8 volts. Turn on the card, we can note that the logical AND gate's output is 1.8 volts. But if we press the reset button, nothing happens. In fact, as you can see, it doesn't clear to 0 volts as it should. So yes, the problem with this card is the logical AND gate itself, and of course that severed trace on the back. Let's go ahead and replace this component and of course repair the trace. Okay, so as I think you may not have seen, I replaced the logical AND gates, and then I rewired the trace on the back over here. I'm not sure how visible it is on camera. Unfortunately, I forgot to hit record when I did the the rewiring and the replacement of logical AND gate, so you might not see very much. But like I said, it has been rewired and the faulty logical AND gate has been replaced. So let's plug everything in and test the logical AND gate itself. Alright, so the first thing we're going to check is the first input of our logical AND gate. Remember before we had 55 or so millivolts? Now, when we turn on the card, you'll notice that we have 3.4 volts, as we're supposed to. And if we check the output, as you'll see, 1.8 volts over here. And much better than this, when we press the reset button, it actually clears to 0, as it's supposed to be. And when we let go, 1.8, and we press reset button, clears to 0, and when we let go, it goes back to 1.8. So yes, now our logical AND gate actually works properly, and we can generally, I think about these intermittently faulty cards is that it's usually a little bit difficult to tell if it's repaired, but I dare say in this case, we figured it out. Anyways, let's put the cooler back on and let's stress test it. Okay, so as you can see, the card's running game. So I should note that at this point, I've actually fixed the cooler. You can see the captain tape, that's why the 2 fans are spinning, and one of them is not at max speed anymore. And also for this particular card, I ended up running it under full load for a whole week, actually, before I sent it back, as I wanted to be sure that it was actually repaired. And it didn't crash once, so yes, I do think it's repaired. Okay, so before we end the video, I want to go over the circuitry one more time. And the particular fault, as I understand that this video is probably not too well put together in relative to my other videos, as these intermittently faulty cards, they're hard to repair at times, and they're also hard to make videos for, as they don't behave the way you want them to, when you want them to. Anyways, so it goes with saying that we had a fault with our PEX reset circuitry, and in particular it was centered around a certain logical AND gate. So if you don't know, these logical AND gates, they require 3 pins in order to output something. So firstly, they require, hold on, let me just delete this, just in case you think it's supposed to be pin 1. It's not. Anyways, so like I was saying, they have 3 pins. So the first pin that you need is VCC. This powers the logical AND gate itself, otherwise it can't perform. So this is supposed to be 1.8 volts, which we did actually have, hence why it's in green. The other 2 pins are input 1 and input 2. So input 2 is 1.8 volts, which we did actually have, which is why, again, it's in green. And as for input 1, this is supposed to be 3.4 volts, derived from the 3 volt standby rail on my motherboard, which is derived from the 5 volt standby rail on the power supply itself. But we did not have this because we had a severed trace. So we ended up with 55 or so millivolts, but we'll just write it as 0 volts for simplicity. So despite the fact that this logical AND gate was missing one of its inputs, it still outputted 1.8 volts to the core itself, I believe, and by extension the card was detected. Now I should note that you might look at this card and think that the problem with the card was that it would randomly crash. In actuality, the real problem with this card is that it's detected at all. A logical AND gate with missing one of its inputs should never output something under any circumstance. And yet we have a weird situation in which we have two faults, but because they kind of cancel each other out, the card was able to boot and run for some small period of time before the logical AND gate would actually revert back to a working state and kill its own output. So anyways, it goes without saying that the repair was very straightforward. We just had to reconnect this trace here, giving us 3.4 volts on our first pin on the logical AND gate, and of course we replaced the logical AND gate because why the hell not, and because it was faulty actually. And of course we then have a proper 1.8 volt output where when you press the reset button, the output goes back to 0 volts, which you should have seen earlier. I should note that when the reset button is pressed, the 3 volt standby rail becomes 0 volts, and by extension input 1 becomes 0 volts, and of course by extension the output of our logical AND gate becomes 0 volts and the GPU clears, and then of course when you let go of the reset button it all goes back to normal and you have 1.8 volts at the output. But anyways, despite this, so despite the maybe not too well explained video, I do hope you learned something. This is kind of a rare fault. It's definitely very weird. But in either case, I hope you learned something watching the video. If my channel or my videos have helped you out, consider becoming a patron, link in the description, and hopefully I will see you in the next one.